Hey everyone, my name is Mr. Emil Viana and welcome to General Physics 1.
Today's lesson is about freefall. Freefall is when objects fly through the air. Also, an object during freefall is only influenced by gravity. This means we exclude forces like air resistance. As you can see, the parachute provides the air resistance, but if we cut the ropes, places the person in a state of freefall. Movement is slower with air resistance, since it acts upward, opposite to gravity. By crumpling the paper into a ball, removes air resistance. By doing so, makes the object move faster. Since gravity is the only force acting on it, the object will be in a state of freefall. Objects in freefall experiences the same acceleration due to gravity, or g, which has a constant magnitude of 9.8 meter per second squared. Observing how g affects velocity. Looking at the image, we see that in every second, there is an increase in the velocity equal to the magnitude of g. In freefall, we are only concerned with the motion along the y-axis. We can observe this by comparing equations from our previous topic, the uniform accelerated motion. In freefall, we use almost the same equation because in uniform accelerated motion, or UAM, we treat the motion along the x-axis, while in freefall, we treat the motion along the y-axis. The y component of freefall is shown. Instead of a, the acceleration, we have a constant g, the acceleration due to gravity, which acts along the y-axis. Another change is the displacement, the d, which is now referred to as the y, the vertical displacement, or the height. Recall that in UAM, we assume that values are zero based on the situation. Like for objects that started from rest, we assume that the initial velocity to be zero. And for the objects that are slowing down to a stop, we assume that the final velocity to be zero. We have the same thing for freefall. Basically, we have two types, just like in UAM. For objects that are dropped, we can safely assume that the initial velocity to be zero, since it started at rest from your hand. And for objects that are thrown upward, we can assume that the final velocity to be zero, since the object momentarily stops at the peak of its motion. Let's try an example. Analyze the problem and write the given. Notice that we have more than one given in this problem. Since the shoe was dropped, the initial velocity is zero. The vertical displacement is negative since the object was dropped and headed downward. And the g is negative 9.8 since gravity always acts downward. This is always indicated because g is considered a constant value. Now we have to find the final velocity. But first, we have to imagine the problem. The building was at a height of 400 meters and the shoe was initially at rest with zero for the initial velocity. But suddenly, it fell with an acceleration due to gravity of negative 9.8 meter per second squared. What was the final velocity just before hitting the ground? By looking at the set of given, we are going to use the third equation. First, derive an equation for final velocity. And since the shoe was dropped, the initial velocity is removed since it's equal to zero. Next, we need to remove the square found in the final velocity by square rooting both sides of the equation. Finally, substituting the values to the equation, we find that the final velocity before hitting the ground is 88.5 meters per second. Keep note, what we were looking for was the magnitude, so if you want to indicate the direction for a vector, you just add the negative sign. Next, let's try a different problem. Now the givens are, since it was thrown upward, the final velocity is 0. Now the time is 5 seconds, and the g is still constant at negative 9.8 meter per second squared. Now we have to find the initial velocity and the height. First, let's imagine the problem. The ball was thrown upward, then it stopped momentarily. Afterwards, it headed downward, and the total time of travel was 5 seconds. But what we're after is not the entire 5 seconds, but only the initial velocity headed upward, and the vertical displacement in the same direction. So this only covers half of the path, which cuts the time in half, making it 2.5 seconds. If the ball stops at the peak of its travel, the final velocity is 0 meters per second, and the g is still constant. Observing the set of given values, which equation will be used? Correct, equation number 1. In deriving an equation for initial velocity, we start the solution by cancelling the final velocity since it's 0. Afterwards, transpose the gt to the other side to give us this equation. Substituting the values, we get 24.5 meters per second. Now for the vertical displacement, and based on our givens, which equation will be used? Correct, it's equation number 2. By just simply substituting the values, we arrive with an answer of positive 30.6 meters as the vertical displacement of the maximum height of the ball. I hope you learned something. See you in the next video. Goodbye!